All right, strap in, everyone. Today, we're diving deep, and I mean deep, into a concept that's kind of mind-blowing, almost science fiction.
Oh, sounds exciting. I'm ready. What are we tackling?
We're going to explore the idea of, get this, quantum singularities as a potential energy source.
Whoa. Okay, that's definitely out there. It's something you've been wanting to get into for a while.
I have. It just seems so wild, but also so fascinating. Like, could we really be sitting on a source of energy that's so powerful it makes nuclear energy look like I don't know, a flickering candle?
Haha. Well, let's not get ahead of ourselves. But it's a valid question, and honestly, one that pushes the boundaries of what we currently understand about physics.
Exactly. I mean, we know E-MC4, right? Energy and mass are interchangeable.
Right, one of Einstein's most famous equations. It basically tells us that mass can be converted into energy, and a lot of it. We see this in nuclear reactions.
Yeah, like when you split an atom in fission, you release a ton of energy.
Right. A uranium-235 atom, for example, releases around 200 MeV when it splits. And in fusion, where you force hydrogen atoms together to make helium, you also get a good chunk of energy out, about 17.6 MeV.
But what if that's just scratching the surface?
Oh, I see where you're going. You're thinking, what if there's an even deeper well of energy inside atoms that we're not tapping into with fission or fusion?
Exactly. And that brings us to this idea of quantum singularities. What if, at the heart of every atom, there's this point of immense energy density, not a black hole in the way we usually think about them, but something analogous on a quantum scale?
So you're proposing that this quantum singularity is sort of like the atom's hidden powerhouse.
Exactly. And it's governed by, well, here's where things get really tricky, the laws of quantum gravity.
Ah, yes. Quantum gravity. That mysterious realm where the immense gravity of things like black holes meets the bizarre world of quantum mechanics.
And that's precisely what makes this whole idea so fascinating and, frankly, a bit terrifying.
I get it. It's like, are we talking about unleashing mini black holes? But that's where quantum gravity comes in. And it might be the key to understanding how these singularities, if they exist, don't just collapse everything around them.
Okay, so let's delve into that a bit. How does quantum gravity play into this?
Well, quantum gravity suggests that at these extremely tiny scales, quantum effects become dominant and could prevent the singularity from becoming a black hole as we typically understand them. It's like there's a sort of quantum pressure that counteracts the immense gravitational pull.
So these quantum singularities would be in this delicate balance held stable by the interplay between quantum mechanics and general relativity.
Exactly. It's like a cosmic dance between these two fundamental forces of nature.
Okay, but even if they are stable, these singularities would have to be incredibly tiny, right?
Oh, absolutely. We're talking about something far smaller than the nucleus of an atom. Smaller, even, than anything we can currently measure directly.
So how do we even begin to conceptualize something that small?
Well, one way is to think about the Schwarzschild radius, which basically describes the event horizon of a black hole. For an object to become a black hole, it needs to be squished within its Schwarzschild radius.
Okay, so how big is the Schwarzschild radius for, say, our sun?
For the sun, it's about 3 kilometers.
3 kilometers. That's like bigger than some towns. But we're talking about something at the heart of an atom.
Precisely. And if we were to calculate the Schwarzschild radius for a quantum singularity with the mass of an atom's nucleus, it would be unbelievably small, much smaller than the Planck length, which is the smallest unit of distance we can theoretically measure.
So it sounds like quantum gravity is absolutely crucial to making this whole idea work.
It is. Without it, these quantum singularities would just turn into mini black holes and gobble everything up. But quantum gravity might provide the necessary safeguards.
But let's say, for argument's sake, that these singularities do exist and are stable. How on earth would we even think about extracting energy from something so incredibly tiny?
Well, that's where things get even more mind-boggling. We might be able to use something we're already pretty familiar with, electromagnetic fields.
Okay, I'm intrigued. How so?
Remember Maxwell's equations? They describe how electric and magnetic fields interact, and we already use them to manipulate atoms in all sorts of ways.
Right, like lasers, MRIs, all that stuff. So are you suggesting we could use finely tuned electromagnetic fields like a tiny tractor beam to interact with these singularities?
That's the basic idea. We could potentially influence the state of the singularity, maybe even excite it in a way that releases some of its energy in a controlled manner.
Hold on, excited. How would that even work?
It's all very theoretical, but we might be able to draw a parallel to how we use electromagnetic fields to manipulate the energy levels of electrons in atoms. We could use a similar approach, but much more sophisticated, to interact with these singularities.
So instead of smashing atoms apart like in fission or forcing them together in fusion, we'd be using a more elegant, almost musical approach to coax energy out of these singularities.
That's a poetic way to put it. We'd be working with the quantum nature of these objects, using resonance and precise manipulation rather than brute force.
I like the sound of that.
It's a pretty wild concept for sure. But if we can even begin to understand the physics of these quantum singularities and how they interact with electromagnetic fields, who knows what kind of technological leaps we might be able to make.
Okay, this is where I think even the biggest skeptic has to lean in. We're talking about tapping into the very fabric of space-time itself.
That might be a bit of an overstatement, but it captures the essence of what we're discussing. We're
Mhm.
talking about interacting with the most fundamental structures of matter, potentially unlocking a source of energy that's beyond anything we've ever imagined.
This is getting really interesting. But before we dive too deep into the how of all this, let's talk numbers. If these singularities really do hold such vast amounts of energy, how much are we talking about?
To grasp the scale of this, we need to think about the Planck energy scale, the highest energy scale that even makes sense in physics. It's about 1.22 by 1019 GeV.
Okay, that's a huge GE number. But how does it compare to what we get from fission and fusion?
Remember, fission and fusion release energy on the MeV scale. So we're talking about a difference of many, many orders of magnitude.
So we're saying each atom could theoretically contain energy trillions of times greater than what we get from splitting or fusing them.
That's what the math suggests. It's a truly mind-boggling idea, but we need to be cautious. We're still in the realm of theoretical exploration here.
All right, before we get ahead of ourselves, I think we need a name for this wild, theoretical energy extraction process.
Definitely needs a catchy name.
How about quantum singularity energy extraction, or QSEE for short?
QSEE. I like it. It's got a nice ring to it.
So QSE it is. It's about tapping into these theoretical quantum singularities at the heart of atoms, using electromagnetic manipulation to maybe, just maybe, unlock a truly staggering source of energy. But there's so much more to explore.
There is, and I'm all ears.
Well, stick with us because in our next segment, we're going to dive deeper into how this QSE process might actually work and what kind of mind-blowing technology we'd need to develop to make it a reality.
This is going to be good, I can already tell. Welcome back, you guys. Before we went away, we were just getting into this crazy concept of quantum singularity energy extraction, QSEE. It's a mouthful, I know.
It is, but the concept itself is even more mind-blowing. We're talking about potentially tapping into these quantum singularities at the heart of atoms, using some super precise electromagnetic fields to maybe extract a ridiculous amount of energy. But, let's shift gears a bit and talk about what this could actually mean for our world, if QSE actually worked, I mean.
Yeah, I think before we get into all the amazing applications and what QSE could do for our future, we should try and wrap our heads around how this energy extraction process might actually work. It's one thing to throw out terms like electromagnetic manipulation, but what would that actually look like?
Okay, yeah, good point. It's all well and good to say we can manipulate these quantum singularities, but we've established that they're mind-bogglingly tiny, governed by the laws of both quantum mechanics and general relativity. How do we even begin to target something that small, let alone extract energy from it?
You hit the nail on the head. That's the million-dollar question. And to be completely honest, right now, we're knee-deep in speculation. But we can take a look at some existing technologies to maybe kind of get a feel for what might be possible. Think about, for instance, magnetic resonance imaging, MRI.
Okay, so MRIs, those giant machines that use powerful magnets and radio waves to create images of the inside of your body. But how does that relate to QSE?
Well, in the most basic terms, MRI and QSEE would both use electromagnetic fields to interact with matter at a super precise level. In MRI, we use these fields to basically manipulate the spin of atomic nuclei, which then lets us create those detailed images we're all familiar with. But with QSEE, we'd be aiming to manipulate the quantum singularity itself.
So instead of getting a picture, we're trying to pull energy out. That sounds, well, ambitious, to say the least.
Oh, it's definitely a huge leap. It'd require a level of precision and control over electromagnetic fields that we've never even come close to before. But remember, we're already doing some pretty incredible things with tech, like laser cooling and trapping to manipulate individual atoms.
You're right. I've read about how scientists can use lasers to cool atoms down to near absolute zero and then hold them in place. It's wild.
It is, and it really highlights our growing ability to control matter on a quantum level. QSEE would take this to, well, a whole other dimension. We'd need to invent entirely new technologies, come up with completely new theoretical frameworks, just to wrap our heads around it, let alone make it work.
Let's say, just for fun, that we actually figure out all the crazy physics and mind-boggling engineering challenges of manipulating these quantum singularities. What would the actual energy extraction process look like? How do we get the energy out?
One possibility, and this is where it gets really out there, is that we could use finely tuned electromagnetic pulses to essentially stimulate the singularity, kind of coax it into releasing energy in a controlled way. Imagine, if you will, gently plucking at a cosmic energy string.
Instead of smashing atoms apart like in fission or forcing them together in fusion, we're going for a more, I don't know, elegant, almost musical approach, just gently persuading the energy out of these singularities.
Haha, that's not a bad analogy. We'd be working in harmony with the quantum nature of these objects, using resonance and precise manipulation, not brute force.
Okay, I'm on board with that. But so we've stimulated the singularity and it's releasing energy. How do we actually capture that energy and turn it into something useful?
That's another hurdle where we'll have to get seriously inventive. Maybe we could develop super advanced materials that can efficiently absorb and convert the high energy particles or radiation that the singularity emits.
So basically like solar panels, but for a totally different kind of energy.
Yeah, exactly. We'd need to invent materials that can not only withstand these insane energy levels, but also convert them into something usable. We're talking materials with properties that right now we can't even fathom.
This all sounds ridiculously complex, but man, is it exciting. Think about it. If we could actually make this work, what would that mean for our world?
It's not an exaggeration to say that QSEE could completely revolutionize energy production as we know it. I mean, we've been talking about the sheer amount of energy these quantum singularities could potentially hold. Imagine if we could tap into even a fraction of that.
It'd be a world without energy scarcity, wouldn't it? No more reliance on fossil fuels, no more worries about the environmental impact of those giant power plants.
You got it. We could potentially power entire cities with devices the size of, I don't know, a car engine, maybe even smaller. It'd change everything about how we generate and use energy.
And we're talking about clean energy, right? No emissions, no radioactive waste.
Theoretically, yes, but just like any new technology, we'd have to be extremely careful. We'd need rigorous research and development to make sure QSE would be safe and sustainable in the long run. The last thing we want is to solve one problem and create a whole new set of issues.
You're right, we have to be responsible about this.
Oh.
But still, the possibilities are incredible. Energy production is just the tip of the iceberg, too. QSEE could revolutionize so much more. Could it even revolutionize transportation?
Oh, absolutely. Imagine cars, planes, even spacecraft, all powered by QSEE. The energy density we're talking about could allow for incredible speeds and ranges, things we can only dream of right now.
Wait a minute, are we talking about reaching other star systems? Like interstellar travel? Seriously?
It's not impossible, you know? If QSE can really deliver the kind of energy we're theorizing, then the distances we could travel would be, well, they'd be mind-blowing. But let's not get too far ahead of ourselves. Even if we could just achieve a small fraction of that potential, it'd be a game changer for space travel within our own solar system.
So we're talking about clean, abundant energy, potentially leading to a revolution in transportation, even space travel. What other areas could QSE have a massive impact on?
The potential applications are practically limitless. I mean, think about fields like medicine, manufacturing, even computing.
Give me some examples. How could we use QSEE in those areas? What would that even look like?
Well, for starters, imagine using precisely focused QSE beams for ultra-precise surgery, targeting individual cells with unbelievable accuracy. Or QSE-powered 3D printers that can create objects with atomic-level precision, leading to materials with properties we can't even imagine right now.
That's incredible. What about computing, though? How could QSE play a role there?
Oh, it could be huge for computing. The energy efficiency of QSE could be a game changer for large-scale computing, especially for fields like artificial intelligence and machine learning, which require ridiculous amounts of processing power. And it could even lead to the development of completely new types of quantum computers.
Wow. So we're not just talking about solving our energy problems. We're talking about a technological leap forward that could change every single aspect of human life.
That's the beauty of exploring these theoretical ideas, isn't it? They force us to think bigger, bolder, to imagine possibilities we never even considered before. But it's super important to remember that QSEE, is still a baby, conceptually speaking.
Right, we're deep in the theoretical weeds here. And even if the physics all works out perfectly, there are mountains of engineering challenges to climb before QSE could ever become a reality.
Oh, absolutely. The challenges are daunting, to say the least. But that's what makes this whole thing so intriguing. It's a journey into the unknown, pushing the boundaries of our understanding. Who knows what we might discover along the way?
We've spent this whole deep dive exploring this mind-blowing and, let's be honest, kind of crazy concept of quantum singularity energy extraction, or QSEE as we're calling it.
It's definitely been a wild ride. We've gone from the theoretical physics behind these quantum singularities to the insane engineering challenges of actually harnessing their energy, and even touched on the potential applications that could, well, reshape our world.
It really has. But before we wrap up, I think it's worth taking a step back and looking at the bigger picture here. We've talked a lot about how QSE might work, how we could manipulate these quantum singularities, how we'd extract the energy, how we could even use it. But I think we should also spend some time on the why.
I like that. It's not just about the science, right? We need to think about the deeper implications of a technology like this, something with the potential to be as disruptive as QSEE.
Exactly. If we're talking about tapping into a source of energy that's fundamentally different from anything we've ever known, it forces us to ask some pretty big questions about our place in the universe.
Oh, for sure. I mean, for centuries, humans have looked up at the stars and wondered about, well, everything. Our origins, our purpose, our future. QSEE, if it actually becomes a reality, could completely change how we think about all those things.
Okay, let's unpack that a little. How could QSE change how we view our origins?
Just imagine if we could use QSEE to create these micro-singularities in a lab setting. We could study them, learn about them, gain insights into the very fabric of space-time and the fundamental forces that govern our universe.
Are you saying we could recreate the conditions of the Big Bang right here on Earth?
It's a possibility. Think about it. We could study how the first particles formed, how the fundamental forces emerged, maybe even find clues about what existed before the Big Bang. It would be like peering back in time to the very beginning of the cosmos.
Wow, that's mind-blowing. So QSEE can revolutionize cosmology, our understanding of how the universe began. But what about our purpose, our place in this whole grand scheme of things?
That's the kind of question philosophers and theologians have been wrestling with forever. But QSE offers a whole new perspective. If we can harness the energy of quantum singularities, it suggests we're not just passive observers of the universe, we're active participants, shaping its evolution.
We'd be able to manipulate the very forces that created the cosmos. That's a pretty heavy responsibility.
It is. And it highlights how important it is to be cautious, to use wisdom. If QSE gives us this kind of power, we need to make sure we use it responsibly, ethically.
So it's not just about the technological advancements. It's about the philosophical and ethical frameworks we develop alongside them.
Exactly. We need to have these conversations, consider all the different perspectives, and make sure that QSE benefits all of humanity, not just a few.
Okay, we've talked about our origins, our purpose, but what about the future? If QSE does unlock all this potential, where does humanity go from there?
That's the big question, isn't it? And only we as a species can answer it. QSE could give us the power to solve the biggest problems we face. Climate change, resource scarcity, even diseases we thought were incurable. We could travel to the stars, explore new worlds, push the boundaries of human knowledge further than we ever thought possible.
It sounds like QSE could usher in a new era of prosperity and progress for humanity. But as you said earlier, we need to be careful, make sure we're using this technology for good.
100%. QSE could be our greatest triumph or our biggest downfall. The choice is ours.
That's a great note to end on. This deep dive into QSE has been a wild ride, from the subatomic realm to the vast expanse of the cosmos. We've explored the incredible potential of this theoretical technology and grappled with its profound implications.
It's been an amazing journey, and I hope it's gotten everyone listening thinking about the future we're building, the choices we make, and the incredible power of human ingenuity.
Thanks for joining us on this incredible deep dive, everyone. And as always, keep those big questions coming. You never know what amazing discoveries are just around the corner.